So we'll now continue our discussion on the operations of functions. We've previously looked at the sum and the difference, the product and the quotient. Our last operation on functions that we're going to cover in this section is what's called a composition of functions or composite functions. So I'm going to begin with the definition so you can see what this looks like. In problems, if they're asking you to find a composition or a composite function, they're going to use this open circle, right? Oftentimes students will look at that and think that it's referring to multiplication. It is not. If they want you to multiply, they're going to do a solid circle. An open circle refers to this composite function that we're about to learn about. Okay, so our definition for composite functions, if we have f composed with g, which is the way that I'm going to read this on the left, then what that's equal to is the function f and then g of x on the inside of that parenthesis. So the best way that I know to tell you to do this, because often they will change the letters, so it's not good enough to just memorize this particular definition. We need to memorize the pattern of what's happening. So what I'll tell you to do is that if you have f composed with g and you are trying to write the definition, I would tell you to write the first letter down first, along with a set of parentheses. So whatever that first letter may be, go ahead and write that down with a set of parentheses. And then the remaining part is going to go inside this parenthesis. Okay, and you can see that now that matches what we have in the definition. All right, so what I want to do is go through that with a different set of letters and make sure that we understand that. So maybe a particular problem looks like H composed with K. And again, it doesn't really matter what letters they use. All right, so applying my definition, I'm going to write the first letter down, so that would be H in this case, and a set of parentheses. And then I'm going to take whatever's left, which would be this k of x, and I'm going to put it inside this parenthesis that I left. And so now I have the definition for h composed with k. Okay, and then we'll also have some problems. I'm going to do one more with you. We'll also have some problems where we have a number instead of the x. So for example, maybe we have a problem that looks like g composed with f, and instead of an x, we have a 3. So as far as our definition goes, it works exactly the same way. You're going to take the first letter and write it down with an open parenthesis. And then whatever is left is going to go inside that parenthesis that you left. So f of 3. And you need to be able to do that. You need to be able to rewrite that definition so that you can work the problems that are coming. All right, so let's go ahead with that in mind and look at some examples. So the first example says, suppose f of x is equal to 2x squared minus 3, and g of x is equal to 4x. And we want to find, we've got 3 compositions that we want to find. So I'm going to begin the first problem by writing down my definition. So again, we're going to put the first letter down. We're going to open a set of parentheses. And then whatever is left is going inside that parenthesis. Okay, so to work the problem, we're going to do 2 substitutions. Okay, so every time you do a composition, you're going to be doing 2 substitutions. The first substitution is that you're going to go inside the parenthesis, because we know that we always start inside the parenthesis. And you are going to put something in that parenthesis that is equivalent to this g of x. So you're going to ask yourself, g of x is equal to what? And you're going to put it inside that parenthesis. So we know that g of x is the same thing as 4x. So inside this parenthesis, instead of writing g of x, I'm going to now write 4x. And that's going to take care of the first substitution that I need to do. Okay, now the second substitution, we now have f of 4x. So we're now just going to work that out. And we've done that before. We did that in the last couple of sections where we looked at function notation. So we know that if we have f of something, we simply go to the f function, and wherever there is an x, we're going to plug in this thing that's in parentheses. So I'm going to go to the f function, and I'm going to put it right there for that x. All right, so I'm going to write that f function out. So I start with the 2, okay, the 2 that's right here. Then I come to the x, so I'm going to make my substitution, keep it in parentheses. So we've got the 4x that we're substituting in. I now have this squared right here. And then I have the minus 3 on the end. Okay, so once that's done, then we just have to simplify. So we know that we square first. So this thing is going to become 2. And when I square the 4x, I square the number and the x. So we're going to have 16x squared minus 3. We continue to simplify. 2 times 16 is 32x squared minus 3. And this will be our final answer. Okay? All right, so let's try it again. We're just going to kind of keep working through this. Sometimes this is a difficult idea for students to really grasp. So on the next one, definition first, we're going to write down our first letter, which is the G. And then in parentheses, we're going to put whatever's left. So in parentheses, we're going to be putting f of x. So that's the first thing that I have to do, is I have to write my definition down. Okay, so once that's done, then we're going to start our 2 substitutions. So the first substitution is inside the parenthesis. I need something that is equivalent to f of x. So what is f of x equal to? Well, we know that f of x is the same thing as 2x squared minus 3. So I'm going to put that in as my first substitution. All right, the next thing I do then is to evaluate the function g. Okay, because we have a g right here, so I'm going to go to the g function, and wherever there's an x, I'm going to plug in what's in parentheses. So I'm going to start with the 4, and then when I come to the x, I'm going to plug in the parenthesis, which is 2x squared minus 3. And then again, we just need to simplify. So we'll distribute that 4. 4 times 2 is 8 x squared. 4 times 3 is 12. So we'll have 8x squared minus 12. All right, so for the last one, we're going to do the same thing. And notice the letters are the same, but it doesn't make any difference in terms of how we work it. So remember, to write your definition, you write the first letter down first, which is a G, and a set of parentheses. And then you write whatever is to the right there inside the parentheses. So we're going to write g of x inside the parentheses. Okay, so that's just your definition. All right, first substitution is inside the parenthesis. You're going to write down something that is equivalent to g of x. So what is g of x equal to? G of x is equal to 4x. So that takes care of my first substitution. Now for the second substitution, we're just going to evaluate. So we're going to go to function g, because that's the letter I have here. I'm going to take this part that's in parentheses, and I'm going to plug it in for the x. All right, so function g starts with the 4. We'll just write that down. Then we're going to come to that x, and we're going to substitute in our 4x. And then we'll simplify. So 4 times 4 is 16, and then we have the x sitting next to it. And again, this takes a little practice, okay? So that's what we're doing here, giving you a chance to practice some of these problems. All right, let's try another set of examples. So if you feel comfortable with it, what you might want to do is pause right here and work these 3 out, and then you can come back and check your answers and make sure that you're on the right track, okay? So I'm going to begin with f of g of x, and I'm going to begin, remember, by writing down my definition. So I write down the f, and in parentheses, I put the g of x. All right, first substitution is to substitute something in for the parenthesis part. So for the g of x, we know that g of x is the same thing as 6x plus 2. All right, so now that we've done that, we will now go to function f, because that's the letter that we have. We're going to take this part that's in parentheses, and we're going to substitute in for the x. So what does that give us? I still have the 2 sitting out in the front. When I come to the x, I'm going to substitute in 6x plus 2, keeping it in parentheses. And then I have the plus 1. All right, and then we'll do a little simplifying. So we'll distribute that 2. So 6 times 2 is going to be 12x. 2 times 2 is going to be 4. Okay, so that distributes the 2 through the parenthesis. And then I have a plus 1 on the end. So combining like terms, we have 12x plus 5 as our final answer. All right, let's do the next one. So on the next one, we're going to write our first letter down, which is G. And then in parentheses, we're going to write down the f of x. First substitution is to write down something that f of x is equivalent to. So f of x, looking back at my problem, f of x is equal to 2x plus 1. All right, from there, we'll go to the g function. We'll take this parenthesis part and we'll plug it in wherever there's an x. So rewriting my g function, I have a 6. I see the x, so I'm going to substitute in my parenthesis. And then I have a plus 2 on the end. Again, we'll distribute the 6. So that's going to give me 12x plus 6. And then we have a 2 on the end. So our final answer will look like 12x plus 8. All right, so for our last one, again, we're going to start with the first letter, which is an F, and open a parenthesis. Then we're going to put whatever's left inside the parenthesis, and that's the definition. Our first substitution is to write down something that f of x is equal to. So f of x is the same thing as 2x plus 1. All right, we're now ready to evaluate function f at 2x plus 1. So we go to function f, and wherever there's an x, we're going to plug it in. So I start writing by writing down the 2. That's the first thing. Then I substitute in for my x. Then I write down plus 1. All right, and then we simplify, so we distribute the 2. So that's going to be 2 times 2 is 4x. 2 times 1 is 2. We have that plus 1 on the end. So we're ending up with 4x plus 3. All right, so after you've checked your answers here, let's go ahead and look at a couple of problems where instead of having x's on the end of the problems, we have numbers. Now, in a lot of ways, this is actually a little bit easier to deal with than having an x. So we start off the same way. We need to write our definition out. Okay, so on this first one, I'm going to write down my f, which is my first letter. And in parentheses, I'm going to write the g of 4. All right, so now we have our definition written down. We're going to work again inside the parenthesis. So what I need to do is I need to calculate g of 4. So I'm going to come off to the side somewhere and see if I can work that out. Okay, so I have function g, and I'm being asked to find g of 4. So I know that that's just function notation. So I know that I'm going to take my function, and wherever there's an x, I'm going to plug in a 4. All right, so it's going to look like that. I'm going to write the 2 down. Where I have the x, I'm going to put a 4, and then I'm going to put my squared term. And then I'm going to work that out. So powers first. So it's going to be 2 times 16, and that's going to equal 32. So when we do our first substitution, and I ask you what is g of 4 equal to, g of 4 is equal to 32. And so we're going to substitute that in. All right, our second substitution now tells me to do f of 32. So again, I know what my function f is. And I know that I want to calculate f of 32. So wherever there's an x, I'm going to put a 32. So I have 1 divided by 32 squared plus 3. All right, so I'm going to use my calculator on the bottom. 32 squared is 1,024. And plus 3 is going to be 1,027. So my final answer here is going to be 1 over 1,027. So like I said, in some ways this is easier because you're working with numbers instead of working with letters or variables. Okay, so let's go ahead and look at the next one. All right, so again, we're going to start with our definition. So we're going to write our first letter down, which is the G. And in parentheses, we're going to write what's left. So that's going to be the f of 1. All right, so first thing I need to do is inside the parenthesis, I need to take my f function, and I need to find something that's equal to f of 1. So I'm going to take my function, and wherever there's an x, I'm going to plug in a 1. So I have 1 over 1 squared plus 3, which will end up being a 4th. All right, so we do our first substitution. We say that f of 1 is 1 over 4, and we substitute that in. Okay, so then the next thing I need to do is g of 1/4. So here's my g function. I need to evaluate that function at 1/4. So again, wherever there's an x, I'm going to plug in a 1/4. So I'm going to have 2 1/4 squared. All right, let's work it out. So if I square the 1/4, square the top, square the bottom, I'm going to get 1 over 16. When I multiply my fractions, I'm going to have 2 times 1 is 2 over 16, which is going to reduce to 1 over 8. And so my final answer will be 1 over 8. All right, so our last one, f of 0, will start out the same way. And again, if you're feeling comfortable, you might want to pause it and try this one first, and then you can come back and check your answer. So by definition, we'll write the first letter down, and in parentheses, we'll put the f of 0. So the first thing I need to do inside the parentheses is take my f function and calculate f of 0. So wherever there's an x, I'm going to put a 0. So that's going to be 1/3. So I can now come back to my problem and actually substitute that in, saying to myself that the inside, f of 0, is 1/3. Now I need to do f of 1/3. So again, I have the function f. I need to go to that function, and wherever there's an x, I need to plug a 1/3 in. So it's going to look like 1 over 1/3 squared plus 3. So simplifying, I have 1 over, when I square 1/3, square the top and square the bottom, I'm going to get 1 over 9 plus 3. Now, we know that we can use our calculator on the fractions, so I'm going to go ahead and let you do that. If I add 1/9 to 3, I get 28 over 9. Okay, so I'm going to go ahead and substitute that in. You can check that on your calculator if you want. All right, and then how do we simplify that? That's a keep, change, flip. So remember that we keep the 1, that's the top. We change the division to multiplication, and we flip the bottom fraction. So the bottom fraction becomes 9 over 28, and when you multiply by 1, you're just going to get 9 over 28. Okay, so I want to show you one other example, and this is straight from Newton. So you might see something like this as you're working your Newton homework, but I wanted to walk you through this example. So they're giving you the graph of a function f and a function g. The function f is in blue, the function g is in red, and they want you to find f of g of 2. And so they've been kind of nice in that they've already written it out with the definition. Okay, and so all we need to do is evaluate these functions at the given numbers. So we're going to work inside the parenthesis first. So the first thing that I'm going to be working on is g of 2. So remember that normally this is g of x. And so if they're writing g of 2, what they are telling me is that the x is 2. So what I want to do is I want to go to my graph, make sure that you're on the G graph, which is the red graph. Go to an x value of 2, right? So here's the 2 on the x-axis, and then drop either up or down until you hit the red graph. So we're right here. And that x value of 2 corresponds to a y value of -1. So what I can do now is I can come back to my problem and I can substitute in for g of 2. I can say I know that g of 2 is -1. Okay, so from there, I need to now find f of -1. All right, so we're looking at the blue graph. Again, remember f of -1 is normally f of x. So again, we know that the x is being played by a -1. So go to the graph, find the -1 for the x, and then you want to go up or down until you hit the blue graph. So this time I need to go up. Okay, so here's my point. And I know that that point has an x value of -1. What is the y value that goes with it? And so we can see that the y value is 3. And so f of -1, final answer would be 3. So keep this problem in mind as you work on your Newton homework.